Welcome back everyone to Data Science for Everyone. Today we're going to be looking at interactive graphics with Plotly Express. Let's get started. So when we're talking about interactive graphics, okay, it's anything that your user can potentially grab a hold of, use, and particularly, again, that the keyword here is interact with. So I'm going to use Plotly Express today. So import Plotly .express. Now there is and let's do this as px. You can use this just Plotly itself, but I prefer to use Plotly Express, particularly whenever I'm wanting to just make prototypes of my interactive graphics. And it's very, very easy. So I'm just going to go through again. This is kind of thing about this. I might need to change this title as a crash course in interactive graphics with Plotly Express, okay? And so this is just to get you guys to get familiar with it. So let's create a data frame here, and I'm going to use only built-in data. Again, it works. This works with any type of data set. So you can import pandas and then import your data set, and it'll work with any pandas data frame as well. And here you can see we have the traditional iris data set. So we have here, if we just take a quick look at, for example, at the species, and let's look at, we want to do the unique. So let's do something like species.unique here. And again, you will see that we have Setosa, versicolor, virginica, and these are the three types in this data set of the types of irises that they have. And in other courses and series over time, you will see we will play with this data set a lot, particularly when we would talk about like classification models, clustering algorithms, that sort of stuff. And you'll see why here once we start plotting everything out. So let's go on with this. And I am actually going to just do this as an inline thing. A lot of people will use Dash, or they'll use Flask or something like that to post this up on their website. But again, since we're just doing some inline stuff here, it works just fine like this. So XP, and we're going to do scatter. We'll take our data frame, and we want our X here to be our sepal width, and then we want our Y to be our sepal length. If you guys aren't familiar with flowers, okay, the sepal is basically the flower part. It's the petal. Okay, and then we have here, we want the color by species, and we can run this, and you will see this pop up. It may take a minute. Now notice this. Look at this. There's pop-ups now. It's automatic for us, okay? This is fantastic. Now, if we want to zoom in, it will zoom in on that data set for us. Okay, we can double click to reset. We have here, we can add in toggle lines. Okay, so then here, when we want to zoom in on an area, it will tell us this. And there's this little pop-up box here that tells us, for example, the species is Setosa, the sepal width is 3.8, the sepal length is 5.7. Now, what's also very useful for this is that let's say that you have these three, but you don't really want to look at any of the Setosa. You can click here and turn off the Setosa presentation, and then it will automatically zoom in on only the points of versicolor and virginica. Okay, and so again, you can have this auto scale. You can do lasso, so you can grab maybe a specific subset you want to zoom in on, and it'll only highlight those in the subset. You can save these as a PNG picture. You can add extra data hover points, and you can customize all of these features individually with Plotly as well. But I'm just going to go over again the most basic rudimentary features. And so let's go back and let's do another type here. And a lot of these are going to kind of mirror what we talked about when we looked at Seaborn as well. So let's do something like px.scatter. And I want here, we'll do df. You know what I'm going to actually just grab this. I want to just redo this. And what we're going to add here with color, let's add marginal y. okay, is going to be a violin plot. And then we'll also do a marginal X, and this will be a box plot. You know, I need to give myself a little bit of room here, so let's put this down. And then we're also going to add in trend lines. Trend line here, and we're going to do ordinary least square, so OLS. And you know what, we can, yeah, let's just run this one and we'll see how this looks. Whoops, there we go. And so here you can see now on these marginals, and again here you can see here that there's going to be some depreciation. Just notice this, that if something breaks that we've used here, probably what's going to happen is that some of this functionality may change just a little bit. Okay, so don't panic about that. Just remember, just always look at the docs. So the things that are different now. Okay, so this is the same plot we had previously up here, but what we've added in are these marginal X. Okay, and so this is a bar, a box plot. Okay, so then here, whenever you hover over, you get the min, the max, and then the interquartile ranges for the statistics. And then the same thing goes over here for the violin plots, but then you get just a little bit extra information here because you also get the distribution of each of the values. And you can see here, as I move up and down, it actually gives me the X, Y coordinates for each of those match up. Okay, and so again, you can still zoom in on these if you want to as well, and notice it changes the values in here as well. So I can double click in here to reset. And then the next thing we have here is our ordinary least squares. And now this is absolutely fantastic when you look at this, because it does give you the proper ordinary least squares trend line equations. Okay, so here you actually say, if you're predicting the sepal length, okay, you have 0.9 multiplied by the sepal width plus 3.9 of some error. And then again, it shows here your R squared value, so you're about 20% likelihood, okay, that this is actually a correct estimate or not. And again, you can see that based on how good the errors are here. And so it gives you a great way to actually kind of see how things are going. Again, you see here, based on sepal length and sepal width, you're going to have a positive trend. And again, you can see that also when it's going to be, the trend here is 7, okay, 7.3. So we can go and look at these others as well. But again, you see mainly a upper trajectory with these. And again, that makes sense because again, as a plant grows, okay, of course its measurements are going to get larger, and so that's going to be the assumption. Okay. Now the next one we can do here is we'll also look with these plots, and what we're going to do is we're going to try and put in these some error bars in here to show there a little bit of difference. Now we're gonna fudge it a little bit by making our own error variable, but you can do this by, if you calculate up the variance or the error that you want, you can always plot this as well. So I'm going to put this back in, and again we're going to use I need to make an error variable in here, and let's just do something like df of our sepal width, and let's say divided by 100, and then color is going to be the same, but then we'll have error x is going to be error, not eder. Error x is, we're going to just make it error, and then our error y is going to be our error as well. And let me give myself some space again, and let's run this to show you guys what's happening. So here you can see this is very similar to kind of like they look like mini box plots almost, but it's giving you this error range plus and minus this error value that we've added in here. Now this is very, very useful, for example, if you're using IoT, so Internet of Things data coming in. You know, for example, that your measurements, okay, maybe your variable measurements or your temperature measurements or your instrument measurements do have some sort of variation that you're not normally used to, okay? This is actually fantastic because then you can put in your errors for each of those variables, those plus and minuses in there, and you would be able to actually look. So for example, here, you can see here like sepal width is this particular value is 3 plus or minus 0.3. And so that allows you to show your user that there is potential measurement error in the data that they're looking at. And this is very, very useful, and it's very, very honest when you start talking about your data. Again, we always need to talk about, when we talk about data literacy and data, we need to talk about truth. Okay, so data, giving as much information as you can to your user and allowing them to trust you is important. And so being able to show that those errors are there shows trust. So let's go on to another one, and we're gonna let's mix it up. Okay, we've been using this iris data set, so let's do another one. Let's do our tips data set. And so you can look here. And again, this is the same data set as we used with the Seaborn library. I'm just pulling it up through Plotly Express's data API. And let's look at just doing some basic plots here. Let's do a bar plot. And so X here is going to be sex, Y here, let's be total bill. Color, let's say, is smoker, and then let's do bar mode here, and we'll say group. And I'll show you. I'll turn off bar mode here in a minute so that you can see what's happening. Now, what's very cool about this data set is you see all of these lines in here, right? These are actually each of the observations that it's showing, and it's connecting them in between, so it looks very nice. So you can actually run through each of these, and as you see, I'm moving around, that pop-up block is actually showing us each of the data points. So then you can just pinpoint data points if you'd like to. If I turn off, yeah, and so let me turn off the bar mode so you guys can see what happens if I turn off bar mode. So if I turn off bar mode, they become stacked bars. Now this is sometimes nice to see because they're nice and stacked, and you can kind of do a comparison. But I find these to be horribly misleading. A lot of people do not know how to read these. Okay, and if again in the future, you guys are probably going to be taking data visualization. I'll be teaching that as well. That's why I would always suggest keeping bar mode as group, so that when you run this, you can actually do a side-by-side comparison. Because and no matter how data literate people believe that they are, they will have a tendency to make mistakes. And so you as a creator have to have the forethought to make sure that you keep people from making mistakes as they would in the future. Okay, and this is the safest way to do that. So let's move on to another one, and so we'll add in facets. Okay, we talked a little bit about facets when we talked about Seaborn. I'm not going to go into a huge digression into what facets are right now, but it's basically able to split up things into two groups, okay, by columns and by rows. So let's do another one, and let's do bar plots again. Bar, and let's do, you know what? Let's actually just do the same exact plot here, okay? But we're going to add in, what do we want to add in? Let's add in our facets. So we want a facet row here, and we're going to do this by time. So that's going to be that lunchtime, dinner time. And then we're also going to do a facet column, and this is going to be by the day. And so that is technically Thursday, Friday, Saturday, Sunday for this. Now, an issue that we're going to have, all right, and let me run this, and you're going to see something, all right? Notice here it's Saturday, Sunday, Saturday, Thursday, Friday. Time is dinner, lunch. It's just kind of grabbing a random entry point into how it wants to visualize this for us. This is no good. Okay, so we need to actually add another line in here, and this is the category orders here, and it takes in a dictionary object. Okay, and you know what, let me actually create up a dictionary object up here so that you guys can see it a little bit better. And so let's call this cat order. And so it's going to be a dictionary here, and we want day. And so this needs, each of these needs to match up with the variable that you're using for that category, okay? It will match them up for you. And then it takes in a list, and then you put in the order that you want. So here we want Thursday, Friday, Saturday, Sunday. Now, be very careful, okay? If you misspell one of these, it's not going to work out for you, okay? So make sure that you keep things correct. So then the next one is time, and it's going to take in a list here, and we want this to be lunch and dinner. Okay, and so I will run this for our category order, and then I will take this variable name, this cat order dictionary, and I'll put it down in here. And now when I run this, we actually get, notice everything is now in the correct order. Thursday, Friday, Saturday, Sunday, and then we have lunchtime, dinner time. Okay, so now we have all of our box plots, okay? And then we have our smoker, which we can, again, we can turn these off or on depending on how we want to look at things. We have our male and female. So this is a very, very dense data, a very dense plot, an interactive plot, okay? We have many things going on, and this is a great way to start getting into using dashboards and creating dashboards, okay? You can start creating user interfaces where someone says they actually will type in something like certain variables that they want, and it will help you generate these nice graphics, okay? Again, that's something that we should talk about a different class, different date, different whole series altogether. But this is kind of the starting point with that. So let's go on and do a couple more. Let's go back to the iris data set, and we'll give a couple more plots because I like using that one, and then we'll go and we'll do something really cool here in a minute. But I do want to show you guys the scatter matrix. A scatter matrix here is F, and then we want our dimensions. Now this is very similar to a pair plot in Seaborn, and what we'll actually do is maybe do something like this. So we'll have a, you know what, actually we'll create this in terms of machine learning. So let's create a features list here, and so let's say that you're interested in the sepal width, the sepal length, the petal width, and the petal length. Okay, so this is very, very useful for when you're wanting to redo or you have machine learning outcomes or a big package or presentation that you're putting together. Having these features saved as some sort of list, you can reuse them over and over and over again, and it helps you be able to create better reproducibility in your research. So here we have features, and then let's say our color here, as before, is going to be species. We can run this. Whoops, what didn't it like? What didn't it like? Dimensions, something. Oh, whoops. Okay, so that's why. Right here, I overwrote the data set. Okay, my DF that I have here now actually is the tips data set. So I need to add in a piece of code here and do df is equal to px.data.iris, and then rerun this. Okay, so now you see here, this is very similar to. It just did a scatter plot with everything in between. Now this diagonal row again is going to be perfect, a perfect line here because it's comparing it with itself. But here you can see it gives you different ways to look at the data, particularly whenever it comes to how things are spread out. So this is just a way to look at everything. If you notice, it's a lot faster than when you do pair plots or something like that with Seaborn. And part of that is because we're actually extracting out what we want here, and the back end of Plotly is actually quite fast. I'm going to, let's skip over and do something a little bit more entertaining and start to do properly interactive graphics. So we're going to grab a hold of the Gapminder data set. And if you guys haven't seen the Gapminder data set in action, this is a great one. Look up Hans Rosling. Okay, his TED Talk is beyond compare. He passed away a few years ago, and so they'll be relatively dated and old. But what we're going to do in this video is we're going to recreate that Gapminder data set visualization, interactive visualization that they use there. So first off, let's do our scatter, the scatter plot here. And we are actually going to do some higher level query action in here. So this is from pandas. And so let's say we want something from 2007. Oh, I didn't actually show you guys the data set. Let me show you that. So you can see here we have a list of countries, the continent that they're at, the years, and it goes from 52 all the way to, I think, 07, I believe, or maybe 08. So we have life expectancy, population, GDP per capita, their ISO alpha codes, and then their ISO numeric codes. All of this ISO alpha and the ISO numeric actually just coincide with the name of the country. So first off, we're going to use this query function, and what this query method actually does, so if you look here, if I run this, it gives us back a data set, and all of the years are just going to be 2007. Okay, and the query method is actually very, very fast. Okay, so this is pandas query method. And I suggest this because it's actually, once you get used to, for example, SQL or something else, you can use this query function very, very quickly. It's very similar to that. But we're going to use that inside of here to subset our data. And here we want X is equal to GDP per capita. Y is going to be our life expectancy. Size here is going to be by population. That's going to make our bubble size. We have color here is going to be by continent. Let me pull this up here. And then we're going to change hover name here to be by country. And then we want the log X axis to true. And then the size max here, max is, I'm actually going to set it to 60 for now. Now, a couple things, let me run this and we'll discuss it. So here we actually see worldwide countries from 2007 where let's go with each of these. So first off, x-axis is GDP per capita. Think about this as how well the country is off monetarily. This is on the log scale, okay? If we didn't use the log scale, things would be bunched up a lot more. Think about the log scale as stretching things out just a little bit. And it's a very common method for analysis and particularly visualization. And then here on the y-axis we have life expectancy. So how long are people going to live? How are they going to feel? And so this is a comparison. The more money they have, the higher their life expectancy is kind of the trend that we see here, right? This is this upward trajectory. Now, when we hover over the names, notice now we actually see each of the countries very clearly. Okay, and that's nice and clear. The colorations are by their continents. So we know in some places, for example, in Oceania, that's going to be New Zealand. Red is going to be Europe. Purple is going to be the Americas. And then the size is by the population. Okay, so again, China has the largest population. Then again, we can see India here, and then maybe Nigeria is down here. Now, we had to set the max size because if we didn't have the max size, these bubbles would just be massive. Okay, we don't want them to grow any larger than that. And I think that has covered everything in there. Now this is nice and all. Okay, it's nice. We are able to show, oh, look here, we see one static image. But That is weak. We have a time series, so we should be able to show movement over time. So let's actually go about this and show movement over time. Now let's do this. Let me actually grab this again. I'm going to put this down here, and we're going to split this up a little bit. So I want, one thing is we're using all the years. Okay, and so let me show you guys how many years we have in the set. Dot, we want year here, dot unique. And so we have from 1952 and then intermittent data all the way up to 2007. Okay, this is the Gapminder data set. So we have our X's and Y's. That's good. Now we need, what do we want here to change? All right, so one thing that we want to add in animation. Okay, so we want an animation frame here, and this is going to be by year. So whenever the data is moving forward, it will be skipping over the year variable. Okay, and then we have an animation group. Animation group is going to be by country. And so what that does is that locks in each of the countries together. So then you're not getting like 4 or 5 observations for China or 4 or 5 or 10 observations for the US. You're just getting each of those individual countries together. Now let's also add in a couple other things here. We want to also split this up. Let's facet. We want this by column, and we're going to add in the country. So we want to split this up by country, and I will toggle. You know what? Let me actually leave this. Yeah, I'll leave it in for now, and then I'll take it out later so we can see a different type of visualization in here. And then now the next thing we want to do is change this max size, because one of the reasons this facet column is going to make little bitty columns for each thing, and we don't want it to be too big. So let's change this to maybe 40. And then we need an X range and a Y range. Range of X. Here we want it from 100 to 100,000. One more. And then we also want the range for the Y to be something like 25 by 90. And the reason is, if you see this, this actually has this very large range in here when we looked at this data, but we want to make sure it's just constrained, because notice here there's a little bit of extra space. We just don't want to waste any of our space. We want to make sure that it's all a little bit bigger and everything's nice and calculated out. So, you guys ready to see something cool? So, this will take a little bit longer to run, okay, because it is doing a lot of other stuff. But, whoops, now what did I mess up with my domain? That was anticlimactic, wasn't it? So let's see exactly where the error was in here. It doesn't like my range data. Why does it not like my range X and my range Y? What happens if, did they change the settings on that? Let's see, let me just delete my ranges really quickly and let me run it and see what happens. If it looks fine, then we're not going to worry about it. All right, and it still doesn't like that. All right, give me a second to see what happened. So now that it's cleaned up, what it is, I had an extra space inside of here. So if we run this, so now notice this, we have all of these columns, this facet columns in here. We have each of the ranges. So again, it is a little cramped in here, and we'll fix that here in a minute. But what's nice is now we have this little play button. So if I hit the play button, we get an interactive graphic where we notice over time the data is moving up. And so what this means is, again, we have fantastic growth over time. So as money goes up over time, people's health has been going over time, and we have this fantastic growth feature. We can also see things that may surprise us, okay? Notice here in Africa, things are going up, and then there's going to be a drop. Oh, Did you see that right there? There's this huge drop, okay? So we had the AIDS epidemic, we had apartheid. And so in those areas, the data just, the bottom dropped out. You can see over here when we watch China again, it goes up and then down, up and then down. And that's, again, we had Mao Zedong, okay? Whenever he came in, it changed the history and the economy. So they dropped down initially, and then once they started loosening restrictions, they started shooting right back up. So you can see all of this interaction going on, and this is much more profound as a story for your users. So if let me just get rid of the there. This is actually what I want here. So notice I like to see this whole thing. Sometimes having everything split up in the columns is different. So I got rid of the column facet and I run it. Now we can actually see the whole thing. You can see the whole world growing over time and changing over time. So again, this adds a profound story. And again, just to reset it, all you have to do is hit play. You can stop it, and you can even turn off areas. So maybe we just want to watch Asia, and we can have it play as well. Okay, and then again, we can turn everything back on as we wish. All right, and I'm going to be ending it here, guys. Thank you very much for everything. If you guys liked it, please comment, subscribe, and join our community. All right, thank you guys. Bye-bye.